Get accurate heating, ventilation, and air conditioning airflow cubic feet per minute fast using the Temperature Rise formula, and learn exactly when to adjust blower speed taps so your measurements match real operating conditions. To measure airflow with the Temperature Rise method, you need clean temperature readings and steady heat input. Put a high-quality fast response thermometer upstream and downstream of the furnace heat exchanger. Avoid radiant influence by shielding the probe tip, and let the system run 5 to 10 minutes to stabilize. Record the nameplate input in British thermal units per hour and the furnace steady-state efficiency to estimate output heat in British thermal units per hour. If you do not have an accurate combustion analysis, use the nameplate steady-state efficiency and note the potential error margin. Calculate airflow as output heat divided by specific heat of air times temperature rise. For standard conditions, use 1.08 as the multiplier for dry air at typical indoor humidity. So airflow equals furnace output divided by 1.08 times temperature rise in degrees Fahrenheit. If return air humidity is unusually high, bump the multiplier slightly, for example 1.09 to 1.11, to offset latent effects. But document your assumption. Take the return and supply air temperatures at the same static pressure reference plane for consistency, and average multiple readings across the duct cross-section using the equal area method to avoid stratification errors. Verify the thermostat is calling for heat only, all zones are open, and filters are new or measured for pressure drop, because a restricted filter will inflate temperature rise and falsely deflate calculated cubic feet per minute. Before any test, measure total external static pressure with a manometer and compare to blower table. If total external static pressure is above the blower chart limit, the temperature rise airflow estimate will skew low. When you need cooling airflow verification but the house is in heating season, set blower speed taps to the cooling tap before testing, or use a jumper at the control board to force cooling airflow while energizing only the blower, not the compressor. One of the most common heating, ventilation, and air conditioning mistakes is testing airflow for heat mode while leaving the blower on the cooling speed, which corrupts the temperature rise and the derived cubic feet per minute. Fix this by matching blower speed taps to the mode you are testing and confirming on the control board legend. Another frequent airflow calculation error is taking supply temperature too close to the heat exchanger, where stratification is extreme, causing inflated temperature rise. Fix by measuring at a well-mixed supply trunk location at least 3 duct diameters downstream of the heat exchanger and averaging several points. A third search engine optimization relevant issue is ignoring duct static pressure and filter pressure drop when calculating airflow by temperature rise, leading to misdiagnosed low airflow in furnace airflow testing. Fix by measuring total external static pressure, checking filter pressure drop against manufacturer specs, and correcting restrictions before trusting the cubic feet per minute number. BigHomeProjects.com lists verified heating, ventilation, and air conditioning contractors with profiles that highlight airflow testing skills, combustion analysis capability, and duct diagnostics, so you can find a pro who will set blower speed taps correctly and measure airflow with confidence. Contractors use BigHomeProjects.com to showcase certifications, collect reviews, and win jobs from homeowners who are actively searching for trusted local experts in airflow measurement, furnace tuning, and system optimization.